Hello students, in this video I will go through steps on inscribing a regular triangle, quadrilateral, octagon, and dodecagon inside of a circle. Let's take a look. So in order for us to accomplish this, what you'll need to do is you need to draw out circles like I have here. I have 4 circles already drawn, and the reason for that is because I want to conserve time. You need to draw a circle, and the way in which you draw the circle is you're going to draw a line first, and then after you draw a line you're going to indicate a point on that line. So again, it doesn't matter how long the line is, it doesn't matter where you place that point on the line. Okay, the idea is you just need to identify a point on the line, that's it. And the reason for this is when you open up the compass to whatever setting, to draw whatever radius setting you have, you draw the circle. What you'll end up with is the diameter. So I have 4 congruent circles here. I encourage you to draw the 4 circles like I have here, and so pause the video to do that first. If you and then when you're done, come back and press play. So hopefully you have all 4 circles drawn. What I'm going to do now is I'm going to draw or construct an equilateral triangle inside of this circle. So the equilateral triangle will be constructed in this manner. What you're going to do is, and this happens rather naturally, right now your compass setting is opened up to the radius of the circle. Hopefully you haven't changed the compass setting. If you did, just measure the length of the radius one more time. And then what you do to inscribe an equilateral triangle inside of a circle, what you're really doing is you're inscribing first, not an equilateral triangle, but you're inscribing a hexagon. Why is it a hexagon? Well, that's because if I take my compass and place my pin on the edge of the circle at the end of the diameter, on one end of the diameter, and I begin marking the circle, the circumference of the circle, and I go around the circle, you're going to notice that I actually am able to go around the circle 6 times. Therefore, the side length of the hexagon that's inscribed inside of the circle is actually going to equal to the radius of the circle. And that's exactly the situation that we have. So I'm going around the circle, and you see that I did 1, 2, 3. This is the 4th one, and now I'm going to go do the 5th. And lastly is the 6th. And if you do this correctly, it should land back exactly on the point where you started, which it does. And then what you do, because our goal here, our objective, was to inscribe not a hexagon, but an equilateral triangle, a regular triangle. So what we're going to do is we're going to connect every other intersections, every other point of intersection here. So I am going to do this. So that's 1. And I'm going to connect these over here. And that will be 2. And last is going to be my 3rd, which is this guy right there. So there you have it. This is an equilateral triangle, and it's inscribed inside of the circle there. And now I'm going to go and try to inscribe a square. So pause the video, see if you can figure this out on your own. Everyone having watched and having gone through the geometry lessons should be on construction should be able to reproduce the next step on their own. So pause the video, see if you can think about it, and then press play to come back. Hopefully you guys had some time to think about this. if we're constructing a square, the diagonals of a square are going to be perpendicular to one another. And not only that, the diagonals are going to be congruent, because as you recall from our unit of study involving quadrilaterals, what makes a quadrilateral a square is the fact that the diagonals are congruent and they are perpendicular bisectors of one another. So because of this, okay, what we're going to do is we're going to construct a perpendicular bisector to this diameter, and once we have the perpendicular bisector, in other words, we're coming up with another diameter, we will then be able to form a square inside of the circle there. So if you recall from how we constructed a perpendicular bisector, we open up our compass to more than halfway, right? Just a little more than halfway. It doesn't have to be all the way across. And we draw an arc below, an arc above. We pick up our compass, we place our pin on the other end of the diameter, and we repeat. We draw an arc above and so below. These 2 points should intersect with the center here, and it does, because the center is also a part of the perpendicular bisector. The center there bisects that diameter into 2 equal parts. So therefore the diameter that I draw that's going to be perpendicular will look like this. And what I have now is I have the diagonals inside of the square, and all I got to do is connect those points of intersections to form my square. So that's one side. I have another. And I have the third. I apologize if I am covering up what I'm doing, but it's hard to do this when you have when I have such low vision and I'm trying to show you guys how to do this. But anyway, I think you guys get the idea. I am just putting this in, right? And I'm connecting the dots. There you go. That's the square. All right. And now I am going to repeat this again. I'm going to move this a little bit. All right. So now I am going to construct, like I said in the beginning of this video, a triangle, square, and now I'm going to try and construct an octagon. So the octagon, okay, how are we going to do that? Well, it's actually going to be the same kind of idea. What we do is, again, pause the video, see if you can figure this out before I'm getting a little ahead of myself. Hopefully you guys had some time to think about this, but it's the same kind of idea. An octagon is an 8-sided polygon where all the sides are going to be the same. So if you think about taking the square that we've made, and if we rotated or bisected each of the sides of the square, then we will have constructed an octagon. So I'm going to repeat the steps one more time. So what I have here, and this time I'm not going to draw in the full diagonal, but instead I'm going to put in just a marking here and a marking there. And I am going to make a mark so I know that these are going to be part of the square. And what I want to do is I want to bisect this line. Okay, so because if I bisect this line, or if I bisect that angle there, I will then be able to find the midpoint, and then I can construct this. So what I'm going to do is, if I were to construct this line here, I'll just draw it in just so that everyone can see it. I'll draw it in anyway. I should have drawn it. So what I want to do is I want to bisect this right angle. So how am I going to do that? I'm going to take the compass setting that I have, and it really doesn't matter, right? I'm going to draw a line here, an arc here, and an arc, place my pin there, and draw another arc right there. Remember how we bisected angles, right? So right now, this is the compass setting. Okay, and what I do is I'm going to construct this. I'm going to connect that point, okay, to make that line. So I'm going to do this. Okay, and actually I'm just going to extend it in the other direction because it's going to go in the other direction anyway. I should have done that without, so going in the other direction. Okay, so I have it going in the other direction, and I'm going to repeat this again by drawing in the other I'm bisecting the angle in the other direction, and whoops, I shouldn't have done that. I place the angle over here, I draw an arc, I place the pin on the other angle, I draw another arc. The intersection, that is going to be my angle bisector. So therefore I am going to draw that line. And I have my octagon here. So if I connect this, I have one side of the octagon. Connect this, I have the second side of the octagon. Connect this, I have my third side of the octagon. And then I have my fourth. And I have my fifth. And then I have my sixth. And I have my seventh. And lastly, eighth. Okay, and then the last thing that I'm going to do is the dodecagon. Move this slightly over. So the dodecagon is a 12-sided shape. How are we going to be able to figure out a 12-sided shape? So all you got to do actually is we're going to take our hexagon here, okay? So I'm going to measure this out. I'm going to measure the radius one more time. To find the to create our dodecagon, our 12-sided shape, we're going to make a hexagon first, and then we're going to double the partitions, or actually half the partitions. Okay? I'm going to go around the circle. And there you have it. I have 6 sides, okay? And then what I'm going to do is I will now break up each of these angles up. So again, what I'm going to do is I'm going to take this point right here, and I am going to make a mark there, place my pin over here, make another marking over here, and by doing this, I will have then figured out the partition of that side of that angle. So I am going to draw that. I'm going to do it again. I'm going to partition these two. So I'm going to place this guy right here, and I'm going to make a marking here. Actually, make a marking here. Place my pin there, make another marking like so. Sorry that this is getting a little too busy, but the idea is you're going to construct this right down the middle. And this will give me, so again, I have 1, 2, 3, 4, 5, and I need to do this again. I'm going to take my compass setting here, and I am going to place my pin here. Repeat this one last time. And once I repeat this last time, and it didn't intersect, I'm going to do it one more time here. So therefore, I take this, and I intersect, and I draw that line in. That's the diagonal of the hexagon there. So all I got to do now is connect all of these sides. So the markings with the endpoints there, so I connect, that's 1, and then this is 2, and then this is 3, and then this is 4, and then this is 5, and then I have 6, and then I have 7, and then I have 8, and then 9, 10, 11, and finally 12. So I have my dodecagon.